In this video, we are going to do various questions with respect to operations on Surd. Previously, we had already understood that how to operate on Surds, like how to add, subtract, multiply, or divide. So in this video, we are going to do plenty of questions wherein we will learn how to solve them. So let's start. The first question is add 3 root 2 plus 7 root 3 and root 2 minus 5 root 3. So we will start first of all by writing the question as 3 root 2 plus 7 root 3 plus, this was the first bracket, root 2 minus 5 root 3. As of now, I have kept them enclosed in the brackets only. Now I will start collecting the like roots. So what we have 3 root 2 and root 2. I will collect them. They both are positive. So it will become 3 root 2 plus root 2. Okay. After that, I will collect root 3 terms, which are 7 root 3 and minus 5 root 3. So 7 root 3 is positive, whereas 5 root 3 is negative. So whatever is the sign, I have just taken down as it is. Now 3 root 2 plus root 2 becomes 4 root 2 and 7 root 3 minus 5 root 3 becomes 2 root 3. So this is going to be a final answer. We cannot simplify it further because what we have got now, root 2 and root 3 are different roots which we cannot add or subtract. Now similarly, let's try with the multiplication in the next question. The question says multiply 3 plus root 3 with 2 plus root 2. So now we will multiply them as you have learned binomial into binomial previously. Okay. So now what we have over here is 3 plus root 3 times with 2 plus root 2. Now what we are going to do over here, we are going to multiply 3 with 2. Okay. So multiplying 3 with 2 gives me 6. Now we will multiply 3 with root 2. That gives us 3 root 2. After this, we are going to multiply root 3 with 2 and that gives us 2 root 3. The last term comes out root 3 with root 2. So that is root 6. Now, in this question, we can see that 6 is the only constant and we do not have any other constant. So 6 remains as it is. After that, 3 root 2. We do not have any other term with root 2 as well. Next, 2 root 3. We do not have any term for root 3. And the last, root 6. We do not have any further term for root 6. So that means this is your final answer for this question. Now, let's do the next one. We have simplify root 3 plus root 2 whole square. Now, whole square means we are supposed to write them like root 3 plus root 2 into root 3 plus root 2. But we are not going to multiply them binomial like binomial. We will apply the identity of a plus b whole square over here, right? So when we say a plus b whole square, this is a square plus 2ab plus b square. This is the identity. So I will apply that in the similar manner. We get root 3 square plus 2 times root 3 into root 2 plus root 2 square. Now what is root 3 square? Root 3 square means root 3 into root 3, which becomes root 9. And root 9 is nothing but 3. So that means when we are doing a square of the number of a square root, the square root and the root gets cancelled, right? So in a way, we are getting the number back, which is 3. Then 2 times root 3 times root 2, that is 2 root 6. And after that, root 2 square. So we are left with 2 over here. Now it has a scope of simplification. And after this, we are going to write a final answer, which is 3 plus 2, that is 5 plus 2 root 6. So this is your final answer over here. Now, Let's start with the next one, which is a division based quotient. And we have 16 root 6 to be divided by 4 root 2. Now, we will write that in a fractional form. So we get 16 root 6 over 4 root 2. We can see the rational component 16 and 4, they are divisible. They leave us with 4, right? So it becomes 4. And now I am capturing both roots in the single root, which becomes 6 divided by 2. This gives us 3. And therefore, the final answer is 4 root 3 over here. Okay. These were the easier questions where you were just adding or multiplying or dividing, right? Now, we will look at the complicated question, which is simplify. We have got a numerator, we have got various denominators, but the bigger thing over here is the roots that we have over here 72, 288, 648. They are not prime numbers. In the previous questions, the roots that we were looking at, root 3, root 5, root 2, root 6, they were prime numbers, or 6 even is not prime number, but we cannot break it further. Okay. Now we will learn over here that how to actually simplify the roots also. So first of all, before we get into addition and subtraction in this question, we need to simplify each of the roots. And how do we do that? We are going to prime factorize them. Okay. So what we are going to do over here, we are going to prime factorize. So root 72 means we are going to do like 72 over here. So this becomes 36. This becomes 18, 2, 9, 3, 3, 3, and 1. This prime factorization is actually a part of your rough, but I am showing it over here so that you understand what needs to be done or how to simplify. So what do we get over here? We have this thing and these pairs, right? So 2 times 3 is 6. For root 72, you are getting 6 root 2 because it was just a single 2 which was left inside. The rest numbers, they had got turned into pairs. Or there is another way to simplify 72 if you can do the calculations orally. You can write 72 as 36 into 2. Now, 36 is a perfect square. So this can be converted as 6 root 2 without a hassle of prime factorization. I will explain the next number in a simpler and quicker manner, like we have done 36 times 2. So the next number is 288. If I break it over here as 2 into 144, what does it give me? Now, 144 is a perfect square, which gives me 12 out. So we get 12 root 2 for root 288. The last number, 648. Now, what is 648? I can see that 648 can be written as 9 into 72, right? And then we can break 72 further as 6 into 36 into 2. So this together number becomes 648. Now 9 and 36, they are perfect squares. So they will get converted into 3 into 6, which is 18. It becomes 18 root 2. Okay, now So now we will start with the simplification over here, and we will put in all the values that we have got in the original question. So that gives us, in place of root 72, I will be writing 6 root 2. Then in the denominator, we had 5 root 72. So 5 comes out, and in place of root 72, I will be writing 6 root 2 plus 3 comes out, and we get 12 root 2 for 288. And the last, minus 2 times 18 root 2. This is what we get as a whole portion. Now, if you see, you have got root 2 in the numerator and root 2 as a common factor in the denominator also, which will take out and cancel out. So, it becomes 6 root 2 over, I'm taking out root 2, and that leaves me with 5 into 6, which is 30, plus 36 minus 36. So root 2 got cancelled. That leaves us with, and in the bracket also, 36 got cancelled. That leaves me with 6 over 30, and hence the answer just turns out to be 1 over 5. The quotient in the beginning had such a bigger numbers, right, with bigger roots. But upon understanding, we broke the roots into simpler numbers, and hence we were able to solve that in such an easier value, which is 1 over 5. Now, let's try another one. The quotient has 2 root 30 divided by root 6 minus 3 root 140 divided by root 28 plus root 55 divided by root 99. So over here also, I'm going to break that into simpler numbers. Now, 30. We know that 30 does not consist of any perfect square, but 30 can be considered as root 6 into root 5. And in denominator, we have root 6. Now, minus 3 root 140. 140 means it is 14 times 10 over root 28, which can be written as 14 times 2. See, how do I understand that I have to break them into 140 as 14 into 10, or 28 as 14 into 2? Because I can see that 140 and 28, they both are common multiples for 14. So that is why I have brought them into similar numbers. And the next, root 55 can be written as 5 into 11 over 99 can be written as 9 into 11. Okay. Now, what we are going to do, I am going to collect the whole numerator and denominator in the single root. So this gives me 6 into 5 over 6 minus 3 outside, 14 into 10 over 14 into 2 plus 5 into 11 over 9 into 11. 11 got cancelled. 14 got cancelled. 6 got cancelled. And over here we can see that 2 and 10 also are reducing to 5. So now I'm getting 2 root 5 minus 3 root 5 plus the last term is root 5 over 9. So that is root 5, and for 9 I am writing 3 because it was root 9. Now what we can see over here, these two are we can easily solve them. This becomes minus root 5 plus root 5 over 3. I can just take the LCM. It gives me minus 3 root 5 plus root 5 divided whole by 3, and that results in my final answer, which is going to be minus 2 root 5 over 3. So in this video, we have learned how to first add the multiple brackets having roots, multiply them or divide them. And after that, we also saw that how to simplify with complicated roots. We could easily convert them into simpler numbers, and then we operated upon by dividing, adding, subtracting, or even over here, we took the LCM, right? I hope you learned everything with respect to Surds. And if you have any doubts, you can always comment and subscribe to the channel in order to get more informative and learning videos. Happy learning!